So in question 11, again, it's important to make the distinction between your initial amount and the amount that you have in your bank after 1 year, after 2 years, and so on. I'd write it out in this way. So we have A is our initial amount. We get our first lot of interest after 1 year, and then after 2 years we get our second lot of interest, and so on. And we see that after 3 years I've got A times 1.035 cubed. So although this is my 4th term, it's giving me the value after 3 years. And just carry that through to the nth term. If I want after n years, then I would be using A times 1.035 to the power n for after n years. And that's actually my n plus 1th term. Okay. So I'm answering the question, after how many years will I double my money? So after how many years will A times 1.035 to the n be equal to 2A, or you could have used, you can use greater than or equal to 2A here. Solving this, well, we can divide both sides by A. We can assume that A, our initial amount, is not negative or 0. So we're looking for when 1.035 to the n is greater than or equal to 2, and we take logs of both sides and use our log laws to bring that power down. So n log 1.035 greater than or equal to log 2. When I divide this time by log of 1.035, again, remember our log graph here. Between 0 and 1, my log is negative. After 1, my log is positive. This is a positive number that I'm dividing by. So I'm still looking for n greater than or equal to log 2 over log 1.035. Evaluate that, and we get n is greater than or equal to 20.15. And now go back and check the context and the sense of the question. After how many years? So this is during my first year going on. This is during my second year, during my third year, up to that point. I'm looking for n to be 20.15 before it's doubled. So that's sort of during my 20th year, during my 21st year, really. So n is 20.15, but we'd be looking for during the 21st year, would be when I would double my money. Okay, so in question 14, we want to be really careful here about when these bounces happen after the 4th bounce. Be careful, we're not necessarily looking at the 4th peak here, or are we? 1, 2, 3, 4, no, after the 4th bounce. So it drops here. There's my first bounce, there's my second bounce, my third bounce, my 4th bounce here. It says how high would it be after that 4th bounce, so we're looking at this height here. It tells us it follows a geometric sequence. This height here is 10, and it bounces to a height of 7. So that point there would be 7, that point there is 10. So if it's geometric, what would I multiply this by to get to 7? Well, I would times it by 7/10, times by 7 divided by 10, so times by 0.7 is my common ratio. So after the 4th bounce, so and here I would just really write down my sequences here, I think. We dropped it at 10. After the first bounce it got to 7. After the second bounce it would be 7 times 0.7, so 4.9. And then we carry on in that sense. After the third bounce, 3.43. and then after the fourth bounce. And I'd really encourage you to just look at the context of the question for this. If you'd chosen to start your sequence at 10, you're actually looking for the fifth term, and you would be using 10 times 0.7 to the power of 4 for our fifth term. If you start your sequence at 7 here, you're actually looking for the fourth term, and you'd be looking at 7 times 0.7 cubed. And they would give you the same answer, both of these. Take you back to there. So it depends how you choose to define your sequence, how you choose to define it. I would definitely just look at the words and allocate words to the terms in your sequence. For part B here, easiest thing to do is continue this picture on. We're only looking for when the ball hits the ground for the 6th time, and here we can see it's already shown up to the 5th time. So let's just go one more up to the 6th time, and we want the total vertical distance travelled. So we can see it was 10 here, 7 up to that bounce. Well, it must be 7 back to the floor there. We know this one here is 4.9. We've worked it out up to that height, but it must be 4.9 coming down again. We know this height here is 3.43, going up and then down. Then we've got 2.401 up and down, and then times that by 0.7 gives us 1.6807, and we're looking for when the ball hits the ground for the 6th time, so to that point. So I want 10 plus 2 lots of each of these amounts, so 10 plus 2 times 7 plus, and so giving us that answer.